Welcome you all to in this another video lecture in the series of computer system architecture, and in this lecture I am going to explain you about number system conversion. That I have divided this screen into two parts, in which in this part, let's say this is the first part, and in which I am going to explain you the concept of that how we can converge from decimal to any of the bases. As we last time discussed, that we have to study four types of number systems, that is decimal and binary, octal and hexadecimal. And on this side, on this right side, or we can see that the second part of this screen, we have this number conversion, in which we have the binary numbers, and we will see that how we can convert from binary to decimal, octal and hexadecimal conversion, right? So let's start with this decimal to binary. As we know that we are all familiar with the decimal number system. It has 10 numbers in it, 0 to 9. So I have this number, suppose 1, 7 and 8, right? So I am just taking this a small number for you, right, without fraction, and then we will see, and I have already discussed in one of my video lecture that how to convert the fraction part. Okay, so in this lecture we are only focusing on the non-fraction part, right? So because they are going to ask in your exams, right? So we have this decimal number 178, which has base 10, and we need to convert it into binary, octal and hexadecimal. Let's say first convert into binary. So to convert this decimal number into binary, what we have to do, we need to divide this number by 2, right? So let's divide this number by 2. So we have 178 and divide by 2, right? So let's divide in this way, right? So here just this way, right? So write 2 here and then divide it. 2 8 is 16 and 1 is here, so 2 9 is 18, right? So we have nothing left, or the remainder is 0, right? Then we have, because 178 is a even number and it's totally divisible by 2, so here now again divide by 2. So we have to repeat these steps until we get 1 or 0. Okay, so at last, right? So 2 divide 89 by 2, we got 2 4s are 8 and 2 4s are 8, right? So we have 1 in remainder, right? Again divide by 2, so it will come out as 22, right? Here is 22. Then this is totally divisible because it's a even number, then we will write 0 here. Then again, because this 22 is not a 1 or 0, so we have to divide it by 2. So divided by 2 is like 2 1s are 2, 2 1s are 2, and then we left out with nothing, because 22 is again a even number, so we have 0 in the remainder, right? And then again you to divide it by 2, right? So 2 5s are 10, right? 2 5s are 10, so we have 1 in remainder. Then again is not 0 or 1, so we have to divide it by 2. So we have this 2 to the 4, and then in the remainder we have 1, right? Again is 2, it's not 0 or 1, so we need to again divide this by 2. So we have like 2 1s are 2 and remainder is 0. So this number is converted into the various combinations of 0 and 1. So to write this number as in binary, so we have to take the numbers from this way, right? In this way, from down to up, right? Or in upward way, or in upward direction, right? So write this. So first is 1, right? This 1 0 1 1 0 1, right? Then we have 1 0 0 1 0 0 1, and then we have 0, right? So in that way we got this number as a binary number, and this 2 is the radix or base, right? So 172 is now converted into a binary number, right? So 1 0 1 1 0 0 1 0, so it's been converted. So you can practice it more by taking some examples, or it's been given in your book, which is Morris Pano, right? In computer system architecture by Morris Pano, and it's in chapter 3, right? Okay, now so let convert this decimal number into octal. So let's take this number 178 and we will convert into this number in octal, right? And then we will see that how we can convert it into the hexadecimal as well. So for decimal to convert this number in octal, we need to divide this number by 8. So let's divide it by 8. So 178 divided by 8, right? So in this way, in the same way actually, that we have converted into the binary number. So in which base we are going to convert this decimal number, okay? We have to divide it by that base. So when we are going to convert this into the binary number, so divided by base divided by 2. When we are going to convert into octal, divided by 8. So let's divide it by 8, right? Okay, so we have this number 8 to the 16, and we have 1 here, and 8 to the 16. So we left out with the 2, right? And then again divided by 8, right? Then 8 to the 16, and 8 is the 24. So 8 to the 16, right? 8 to the 16. So we have 8 to the 16, right? So we will left out with the remainder will be 16 minus 6, 22 minus 16. It will left out with 262, right? So it's been converted. So we have to write in the same way, from up to down direction. So it will be 262. So one thing that we need to keep in mind here, that in binary we have only two numbers, 0 and 1. So we will divide it by 2 until we get 1 or 0. But in this case, when we are going to convert the decimal into octal, we will divide the decimal number by 8 until we get a number from 0 to 7. From 0 to 7, because in octal number we have the 8 numbers starting from 0, 1, 2, 3, 4, 5, 6, 7. So if you don't know the numbers that are in these number systems, or how many numbers are there in these number systems, you can refer or you can watch my previous videos on number systems. So right, okay, so we left out with 2 here, so we have 262, because in that case we come out with the 2, so we have 262. Again, when we are going to convert this number into hexadecimal, we have to divide this number by 16, right? By 16. So let's divide this number by 16, and 16 ones are 16, right? 16 ones are 16, and it is here it is 1, right? So it 18. So 16 ones are 16 again, and we the remainder will be the 2. Remainder will be 2. So here we have this number is not divisible by 16, okay, because this number is very less. So we have 16 numbers in hexadecimal starting from 0 to 15, in which after 9 the hexadecimal number for 10 is A, and 11 is represented by B, 13 is represented by C, 14 is represented by D, 15 is represented by E, and 16 by F. Okay, so we come out with this number 11 and 2, and 11, as I just told you, and if 11 is represented by B, so we will write B here, right? So we will write B here, right? So it's B, is B, right? It's B, right? So what we have to write here, B, 2, and base is 16. So in that way we have converted the decimal number, any of the decimal number, to its binary, to octal, and to hexadecimal. Okay, these questions are asked in your exam, so please be prepared for that, and practice it more and more. And if you have any doubt regarding this conversion, that how we convert a decimal number to any of the given radix or base number system, right, or either it is binary or octal hexadecimal, you can let me know in the comment section, right? So now look at this second portion of this lecture, which is that you are given with a binary number, and you have to convert this binary number into decimal, octal, or hexadecimal. So how can you do that? So it's just the opposite of this, because okay, so let's take some example. You can write this is a binary number, right? 10 10 11 11, right? So we have this number, and this is in binary, so let me write in this way as the base is 2, right? So I have to convert this number into decimal. Decimal has the base 10, octal has the base 8, right? And hexadecimal has the bases 16, right? So how to convert this into, right, this into into these number systems? So that do it one by one. So first of all, we have this number. So for this number, what you have to do, you have to just write from right to left the numbers, like starting from 0 0 1 2 3 4 and 5, right? So when you have written this number above these binary number, so what you have to do, you have to do that when we are going to convert it into the hexadecimal, into the decimal number, so just consider the base, right? So for that, what you have to do, you have to calculate in a way like, let's start from this, right? Start from this way, right? So we have 1 here, so we will write 1 here, right? We will write 1 here, and then we will multiply by it into 2 raised to power 0, right? So these numbers that I have written above this binary number 0, 1, 2, 3, 4, 5, these are the numbers represent the powers of the 2, right? So we have 2 raised to power 0. Again, this one is 2 raised to power 1. This 2 is 2 raised to power 2. So let me write this in this way, right? Plus, so we have to sum up these powers by multiplying the respective number. So we have 1 here, and multiply it by 2 raised to power 1. 2 raised to power 1, right? Then plus we have here 0, so we will write 0 multiply by 2 raised to power 2, right? Then add this term, this one, okay? 1 multiply by 2 raised to power 3. So 1 multiply by 2 raised to power 3. Then we have this, right? Plus, because this is not finished, right? So we have here 0, okay? 0, and then we have this number position is 4. So 0 into 2 raised to power 4, right? 2 raised to power 4. Plus we have this 1 multiply by 2 raised to power 5, okay? Then equal to, so this if I calculate this, so it is 1 into 2 raised to power, which is 1, because if we calculate the power of 0 to any of the number, it evaluates as 1. So equal to, it will be 1 in this case, plus we have 2 raised to power into 1, okay? 2 raised to power multiply by 1, it will come out with 2, right? 2 plus 0 multiply by 2 raised to power 2. So that means 4 multiplied by 0, it will be 0. So write 0 here. Plus we have this 1 multiplied by 2 raised to power 3, which is 8. Multiply by 1, it come out as 8, right? Plus we have this 0 multiplied by 2 raised to power 4, which is 16 multiplied by 0 will be 0, right? Then we have this 2 raised to power 5, which is 32, multiplied by 1, it come out as 32, right? So you can sum up this number, it will be 43. It will be 43. So this number is 43. So this binary number is converted into the decimal, okay? So when you will practice it more, you will see that we don't need to consider the zeros in these number, because it will evaluate to 0. So but I have written this because just to explain the concept of this binary to decimal, right? You can ignore it as well and consider only the ones and with their powers. Okay, so when you are going to convert this number to octal, it is very easy, because in octal what we have to do, we will make group of these three. From right to left we have to make group of 3 bits, right? So 1 1 0, and then again this is 1 0 1, right? So in decimal, this 0 1 1 is stands for 3. So when you convert 3 into binary, it will come out with 0 1 1, and then this 1 0 1 is right 5 here. So how we have written 5 directly here, because 101, when you convert 101 to decimal, it will be 5. So if you don't know how to convert the binary to decimal, I have just explained the concept, right? So write 101 and then write 0 1 2 above that number and multiply it by putting the numbers in powers of 2, and then it will come out with 5, right? So when you are going to convert a binary number to octal number, or when you are converting to octal any of the binary number, what you have to do, you have to move from right to left and then combine 3 bits at a time. So there can be questions in your mind. So suppose if you have this number, right, like this number 0 1 1 0 1, right? So if you have this number and you have to convert this number into the octal, so here we have to make a group of 3 bits, right? So 1 0 1, so there will be one group of these 3 bits, and for this we have only 2 bits. So in that case, what you have to do, you will insert one more 0 here, right? So that will make a group of these 3 bits, right? So if you have fewer bits, or if you have bits less than 3, and that's not possible to make a group of 3 bits, because as in this case we have only these 2 bits, so in that case we have to insert more zeros from the left side. So the number of zeros will be depend on the numbers, the actual numbers that are given. So here we have given only 2 bits, 0 and 1, so I have to insert one more zeros. But if in that case, if only I have this 1, not the 0, so I will insert the 2 zeros. Okay, so that 101 is 5. You know it, why it is 5, because if you convert it into decimal, you will come out with this 5, and then 001 is your 1, right? So that will be 1 5. So 1 5 will be into the octal representation of this. So in that case, when there is no possibility to form a group of 3 bits, you have to insert zeros from the left side. Okay, and for the hexadecimal, let me write this in here neatly, you know? So 1 0 1 and 0 1 1. So this is the same number that I have written here, but to understand that conversion into hexadecimal, I have written these bits here, right? So okay, now when we are going to convert this number into hexadecimal, we have to make a group of 4 bits from right to left, right? So 1 2 3 4. So make a group of 4 bits starting from right to left. So we have 1011. So 1011 is your 11. 1011 is your 11, and you can convert it into the decimal, and you will come out with this 1011 number as 11 in decimal, right? But in 11 in decimal, okay, it's okay that it's 11 in decimal, but in hexadecimal this 11 is represented as B, right? Is 11 represented by B, so we will write not 11 but the B. What will write? We'll write B, right? So we'll write B. So here B, right? And delete this. Okay, 1. So right, and you know why I have written this B here, because 1011 in decimal is come out with 11, and in hexadecimal we represent 10 as A, 11 as B, 12 as C, 13 as D, 14 as E, and 15 as F. So that's why I have written B here, and here we have only 2 bits. So but we have to make a group of 4 bits. So we have only 2 bits. So what we have to do, we have to insert 2 zeros here, right? We have to insert 2 zeros in that case, as we have done in that example when we are converting into the octal numbers. Okay, so in that case we have to include 2 zeros, because if we are increasing or we are inserting the zeros from the left side, it will not impact the numbers, right? It will not impact the numbers. Impact of the numbers means it will not convert the meaning of this number. So 0010 will be 2. 0010 will be 2, because 10 is 2. 10 is 2. We know, and we have used 2-bit combination in multiplexer, demultiplexer, and in many combination circuits, in AND gate and OR gate, and not AND OR, XOR, NOR, XNOR, and in various gates we have used these combinations, 2-bit combinations, when I used 00, 01, 10 and 11. So if you convert this 10, it will be 2, right? And how many or the number of zeros, any number of zeros I can insert from this side. Okay, it will not affect the meaning or the value of this 10, because it is 2. So here we will write 2 B and base 16. So in that way we can convert this binary to hexadecimal conversion, and in any of the number systems. So I hope this lecture will help you to increase your knowledge about the number systems, right? So thank you very much, and let me know if you have any query or any questions regarding that. Thank you very much.